So we've been working with compound interest with different compounding periods. So that entails that a bank is waiting for a certain amount of time period to pass before they calculate interest. Not everything waits for a time period to pass. For example, interest can be compounded continuously. So the most realistic application for compound interest that's accumulated continuously would be like population growth. But let's just go back to that bank example where something's being compounded for a period. So the word continuously is a cue for a different formula. The compound interest formula for continuous compounding periods is A equals A naught times e to the RT. So let's just define these variables first. A is still the amount you end up with. A naught is still your initial amount. In this case, R is still your interest rate. But we're going to be a little more general with that. It's not necessarily an interest rate. It's the rate at which something is increasing or decreasing. So it doesn't just have to necessarily be an interest rate. It could be a rate of improvement or a rate of decay. So, and T is your time period. So if a word problem comes up and you see the word compounded continuously, that's your cue to use the other compound interest formula, which includes an E. So you may be saying, what the heck is that E? What is it? You're defining all the variables here except for E. Well, that's because it's not a variable. E is the natural exponential function. Just a couple of things about the base E. E is an irrational number, just like pi. Pi is an irrational number. It's a number, not a variable. So is E. E is a number. It's not a variable, it's a number. Very important. So y equals e to the x power is an exponential graph with a base of e. So if we have like y equals 2 to the x power, well, that's an exponential function whose base is 2. Y equals e to the x power is also an exponential function with a base of e. So let's just take a look. The calculator has a button for e, so you can find it very easily. If you look on the left column of your graphing calculator, there's an e to the x function right there. So if you ever want to calculate e to a certain value, second ln, and it'll automatically open up the set of parentheses for you. So e to the first power, let's see what e is even equal to. So now you can see that e is an irrational number, which is approximately 2.718. Just like pi is 3.14, e is 2.718 and change. It's irrational, so it goes on forever. Also, there is an e button. That's just e, not to any power, and that's second divide. So second divide will give you e. If you push enter, it'll return e's value for you. So it's important to remember that e is not a variable, it's a number. So here's the graph of y equals e to the x power. Just remember how we can determine which is exponential growth and exponential decay. This is exponential growth because the base is larger than 1. So it's exponential growth. However, if I made this y equals e to the negative x, well then the x value is becoming the opposite sign. This x value becomes that x value. This x value becomes that x value. Therefore, the graph would look a little different. Now it would be exponential decay. Okay, so that's how we determine whether it's exponential growth or exponential decay with the value of the base. If the base is larger than 1, it's exponential growth. If the base is less than 1, the reciprocal, it's exponential decay. So let's go through an example. Let's say we have an example here that says a bacteria culture has an initial population of 1,000, which is increasing continuously. Before I go any further, that's my cue to write the formula with continuous, increasing and decreasing. So it's increasing at a rate of 3% per day. So let's pull out all of the values that we have here. We have an interest rate of 3%, which is 0.03. We want to know what's the size of the culture after 5 days. So we have a value of t of 5, and we have an initial amount of 1,000. So all we have to do is really plug it into the formula, and the rest is all calculator work. So let's plug all this information in. So we have A equals A naught e to the RT power. A is what we're looking for. We're going to know how much we end up with. A naught was 1,000. E is a number, not a variable. You're not substituting for that. The rate was 3%. Make sure you're expressing this as a decimal, so 0.03 for 5 years. So now let's just recall the order of operations here. Let's calculate e to that power, and then we'll multiply it by 1,000. So we're going to do 0.03 times 5. That was the exponent of my exponential. So it's e to the 0.15. A equals 1,000 e to the 0.15 power. So let's calculate e to the 0.15 power and then multiply by 1,000. The last thing you'll do is multiply by 1,000. So let's load up the calculator and do second e to the 0.15 power. Enter. And now I have to multiply this value by 1,000. So I'm going to use the answer function in the calculator. Second answer times 1,000. Enter. So there's the amount of bacteria that we have in our culture. Just keep in mind, you can't have a portion of a bacteria, so we're going to round accordingly. So the bacteria culture, we're going to truncate the decimal, 1161. So A equals 1161. Now I'm going to conclude this with a statement saying the bacteria has a population of 1161. Okay, let's do one more example. Let's say that Mr. Harris invests in an account that compounds interest continuously. I'm stopping right there. There's my word continuously. That's my cue to write the compound interest formula, which contains the natural exponential function. A equals A naught e to the RT power at a rate of 2.5%. So there's my interest rate. The account was started 5 years ago and is currently worth $650. How much was his initial deposit? So in this case, we're looking for that. We're looking for the initial investment. So we're given how much we end up with. We know the interest rate. We know the time period. The only thing we're missing here is A naught. So let's plug in all the information that we know. The information that we know here. A, 650. That's how much I ended up with. A naught is what I'm looking for. E is not a variable, that's a number. R, 0.025. And the time period was 5 years. So now I'm going to figure out what this number is, and then I'll have to divide 650 by that number. So let's figure out all this in the calculator. And let's see, e to the 0.025 times 5. So 0.025 times 5. And that's the exponent of your exponential. So second e, second ln, to the second answer gives you 1.133. Now I'm going to write this number down. That's not the number I'm going to use. I'm going to use the answer function in my calculator. But I'm going to write this to see what my next step is. E to our power is 1.133. So we have 650 equals A naught times 1.1, can't seem to remember what that was, 1.133. So we just have to divide by 1.33. And this is simply to see what operation I have to perform. So A naught is equal to the quotient of these two. So I'm going to divide by 1.33. 1.133. 33. Again, I'm not using this number. I'm simply writing it to see what my procedure is. I'm going to use the answer function in the calculator. So 650 divided by answer is going to be my initial investment. So let's go back to the calculator and do 650 divided by that second answer. So now we can see that my initial investment was $573.62. So A naught is 500, memory is working against me today, 573.62. Oops. 573.62. So his initial investment was $573.62. Let's think about this another way. So that, let's get rid of all this and set this up a different way. There's another way we could think about this. We could say, all right, we're starting with, well, let's write the compounding continuous formula before we do anything. Now let's read the question and say, if the account was started 5 years ago, so I can say that t equals -5. Rate is still 0.025. So I can think about it this way, that I started with $650. I started there, and I'm losing money until I get to my initial investment. So I can say I started with $650, I'm losing my money. Let's see how much I get after I lose all of this money. So in this case, I'd be looking for A, how much I end up with. So A equals 650 times E to the negative 0.025 times -5. And if you do this all in your calculator, you can plug it in just the way it looks. 650 E 0.025 times -5. You plug it in just like that. So 650 E to the 0.025 times -5. Enter. And there we go. You can see, proof is in the pudding, same exact value that we started with.